Hello, today we are going to solve linear inequalities, a system of those. And so I have two linear inequalities here in my example, and the directions say that we need to solve. So, in order to do this, we are going to graph each inequality and figure out, like normal, the solution, or in this case, solutions that would apply to both of these inequalities. So let me start with this one right here. Now, we talked about many different ways that we could graph a line, and I'll start this version by doing the version where we find the two intercepts. So first I'm going to put in 0 for x and figure out what y is. Well, if I put 0 in for x, we get 0 plus 3y is greater than 6. So my y value is going to be 2 when I divide by 3. All right, and let's try it where I put 0 in for y. Well, we get x plus 3 times 0 is greater than 6. 3 times 0 cancels, and the result would be 6. Now these 2 points, 0, 2, and 6, 0, are on the line itself, if you recall. So I'll put these 2 points here, 0, 2, and 6, 0. There it is. And these two are on the line itself. However, x plus 3y is simply greater than 6. It's not equal to 6. So we cannot include the points that are on the line. So we get a dashed line going through here. And we need to figure out which way to shade. Well, my question is 0, 0 actually going to be on this line? So if I put 0 for x and 0 for y, is this a true statement? Well, the entire left side becomes 0. Is 0 bigger than 6? And the answer is, of course, no. That's not true. So we're going to shade away from 0, 0. 0, 0 isn't a solution, so we're shading above. All right, let's do the second equation next. And this one is in y equals mx plus b form, sort of. I mean, it doesn't have the equal sign. But we can look at this and figure out our y-intercept is -1. Our b is -1, and our slope is 2. So I can go up 2 and right 1, up 2 and right 1, up 2 and right 1, and so on. And here are all the points that we could possibly find on there. And once again, y is simply less than 2x minus 1. So I can just dash, 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 dash. And we want to determine whether or which direction we're shading. Well, here's the actual line, 2x minus 1, and my y's are smaller or less than that. So I should be shading downward toward where y's are less than this line. And then we simply want to find the spot where this is true for both of these inequalities. And this line pointing upward here and this line pointing leftward or rightward, here, indicates that it's this entire section going on forever and ever in all those directions that would carry the solutions to both. For instance, if I look at, say, here's the point 7, 7. If I look at 7, 7, is that going to be true for both? Well, let's test it on top. Is 7 plus 3 times 7 greater than 6? Well, is 7 plus 21 greater than 6? Sure is. How about the bottom one? If I do 7 less than 2 times 7 minus 1, or rather 7, here we go, is less than, we get 14 minus 1. Yeah, and sure enough, 14 minus 1 is 13. That's bigger than 7. So this works out. And so all of these solutions in green, all these ordered pairs would work for both of these inequalities, and so we have solved, and we are done.